about to prove similarity is the AA Similarity postulate. But first, let's talk about what we know about triangles already. It says that the sum of three angles in a triangle is always how many degrees? Right. And if two angles in a triangle are congruent to two angles in another triangle, then the third angles in those triangles must also be what? Congruent. Good. In other words, if we know two of the angles, we can always find the third. And if the other two are the same in our triangles, then the third is going to have to be the same too, right? If they have to add up to 180, that's just how it works out. So let's say we had two triangles here. Maybe they're both right triangles. I know this piece and then this triangle is a lot bigger. So I know that they're both 90. And let's say we also know that this angle here is 40 degrees and that this angle here is 40 degrees. Even though we only know two of the angles, do we know that the third one is going to be congruent as well? Yes. What would the third angle have to be in this case? 50 degrees, right. So I can say that I know that both, I'll put these as x's. So both x's must be 50 degrees because we said that all the angles have to add up to 180, right? So that leads us into the AA similarity postulate, or the angle-angle similarity postulate. And this says if two angles of one triangle are congruent to two angles of another triangle, then that's enough information to prove that your two triangles are similar. And remember, similar is this symbol right here. It's basically the same as the congruent symbol, just without the equal sign underneath it. Okay? All right. So it says, what is the AA similarity postulate actually saying? It says if two triangles are proven to be similar using the angle-angle similarity postulate, then all the characteristics of two similar figures will apply, even though we only know two of the angles are congruent. So remember, yesterday we said the properties of similar figures were that all the angles were congruent and that all the sides are proportional, right? So you're automatically going to know that your sides are proportional, even though you haven't done the math to prove it, because you've proved that you have two congruent angles. So it says we're going to use this in the diagram to the right to complete the statement. So our paper says angle A, or it should have angle there, is congruent to angle F, and that angle B is congruent to angle E. So by the angle-angle similarity postulate, that means these two triangles are similar. They then ask, what is the similarity ratio of ABC to FED? So remember yesterday, we said that to come up with a similarity ratio, you just pick corresponding sides and you make their numbers into a fraction, right? So what would be some corresponding sides we could pick here that are both numbers? Okay, so I could put 25 over 15. And what does 25 over 15 simplify to? 5 thirds. Good. So my ratio, or my similarity ratio here, is 5 over 3. Okay, it says because AC are the first and last letters and FD are the first and last letters, we can use their links to find the similarity ratio. When the values for x and then find the values for x and y. So now they have FD, which is from the smaller figure on the top of the fraction, and AC on the bottom of the fraction. So whenever we fill in these gaps, we need to make sure that we put this different pieces in the appropriate place. So of the two numbers we picked, 15 and 25, which one belongs to the triangle with FD? 18. So the 15 over said that the 25 was the piece that went with it, and that does belong to the triangle with side AC. Alright, so then I just need to fill in the simplification, which we already said was 5 over 3 up here. Well, if it's flipped over, it would be right. And that is something you can use in all of your proportions. Right? So, first they want us to fill in this statement, triangle ACB. So they went from A to C, C to B. So I would name the second triangle what? Good. And then I just need to fill in these ratios because they want us to solve for x and y. So I have 25 over, that side was 15, right, is equal to something over 12. Well, 12 is in the smaller figure. What corresponds with 12 in the big figure? Good. All right, and then for the next one here, I again would have 25 over 15. 18's from this figure. What corresponds with it? Very good. And then you could cross multiply and solve to find x and y. Right? Okay, once you have that, if you will flip over onto the back, it says for the next problems, it hasn't misnumbered here, but determine whether the triangles are similar. If so, give the similarity statement, the similarity postulate, and the scale factor. Okay, so on these problems, remember, all we need to do to prove that they are similar figures is have two pairs of congruent angles, right? So on number 4, how many pairs did they mark for us? 1. They got one pair of congruent angles. Is there any that are not marked that we could add in? Vertical angles. So now I have two pairs of congruent angles. That's enough for me to say, yes, these two figures are similar by the angle-angle similarity postulate. All right, so they said to determine if they were similar, we said yes. We already said what postulate they were similar by. We do need to give a similarity statement. So I would say triangle ABC is similar to triangle what? Good. All right, and then the last thing that they ask us to give is the scale factor. Remember, a scale factor is the same as your similarity ratio. So you just pick a pair of corresponding sides and put them into a ratio. So let's say we look at side AC. That side's 27. What corresponds with that?
18.
Very good. So I can put 27 over 18, or you could flip it over, right? Doesn't matter which direction. 27 over 18, though, would simplify to what?
3/2.
Good. Or 2/3 if you had it flipped over, right? So there's my scale factor or similarity ratio. Good. All right, on the next figure, how many angles did they tell us are congruent? How many pairs?
1, 2.
What?
One.
Just one. They told us we have 90-degree angles. Now, we don't know what the missing angles are, but we could find them, right? Okay, well, if this one's 90 and this one's 48, what would angle F have to be?
42.
Good. And if this one's 42 and J is 90, what does L have to be? 48. Okay, so now do I have at least two pairs of congruent angles?
Yeah.
So I can say that yes, these two figures are similar, again, by that angle-angle similarity. So now I just need the statement and the ratio. So I'm going to say that my triangle HFG is similar to triangle what? Good. And then I just pick corresponding sides and make a ratio. Well, the only sides they gave me were the 10 and 8, right? So I put 10 over 8. And what does that simplify to?
5 over 4.
5 over 4. Or 4 over 5 if you have them flipped over, yes. Since they're not specifying which one we have to put on top, it really doesn't matter. You can pick. Alright. Let's see here. Next picture. So how many angles did they give us that are congruent? One. Here and here. Okay, but I do know 2 of the 3, so I could find the third, right? So on the first triangle, what would angle R have to be? 60 degrees. And what would angle V have to be in the other figure? 80. So do I have more than one congruent pair? So they said if you don't have enough information to prove it, you write that they are not similar. So we don't have enough information to prove it here, so I'm going to say that these are not similar. Our reason here is because we only have one pair of angles that's congruent, right? So only one angle is congruent. Okay, next drawing, number 7. How many pairs of congruent angles do we have here? One pair. Is there any that they didn't mark that we could add?
Angle H, because it's the same angle.
Right, they share angle H. So I have a second pair there, and that's 2 pairs. So I can say that yes, these 2 figures are similar, again, by that angle-angle postulate. And then I just need to make my statement and give the ratio. So I can say triangle HGJ, which is my smaller one, is similar to triangle what? Okay, good. Alright, and then I just pick some corresponding sides. So let's say we start with the small figure, and I'm looking at side HJ. So HJ is 28. What's the side that corresponds with HJ in the big one? H to K, so the whole way. So how long is HK? 40. Good. Make sure you tell me the whole line there. And 28 over 40 will simplify to 7 over 10. If you have it flipped over, yes, 10 over 7. Alright, this is the last one where we have these instructions for them. On number 8, we've got one congruent angle because we have a shared one up there, right? That 85. What would, in the top triangle, the angle at Z have to be? We've got 85 and 45. 50. Good. And what would angle U have to be? 40. So do we have 2 pairs of congruent angles? No. So I'm going to have to say that these are not similar. Okay. All right, last one, number 9, says they want us to set up something to solve for M. Well, we can set up a proportion, but to set up a proportion, you have to know for a fact that your figures are similar. So they gave us 1 pair of congruent angles. Is there any that we could add? Vertical angles. So now I know that these are similar figures because of the AA Similarity postulate. Now I can set up a proportion. So I pick corresponding pieces that are both numbers for my scale factor. That would be like 15 over, good, is equal to, good. And then we just cross multiply, right? Okay, so I've got 10 times m plus 5 is equal to 15 times m. So make sure you distribute that 10. What am I going to get?
10m.
Good. Then what should we do? So m must